In this video, we will discuss the concept limit. Now, let's understand indeterminate form through an example. Here, there are three cases. 1. 2 by 2 equals 1, 3 by 3 equals 1. Here, the numerator and denominator are same. So, the answer is 1. 2. 4 by 0 equals infinity, 5 by 0 equals to infinity. Here, the denominator is 0. So, the answer is infinity. 3. 0 by 6 equals 0. 0 by 7 equals 0. Here the numerators are 0. So the answer is 0. From the above examples, we can say that 0 by 0 may be 1, infinity or 0. And it satisfies all the above conditions together. Case 1, case 2 and case 3. These three conditions together. So 0 by 0 equal to 1, infinity or 0. That means in 0 by 0, both the numerator and denominator are same. So it may be 1. In 0 by 0, the denominator is 0. What is here? The denominator is 0. So it may be infinity. In 0 by 0, numerator is 0. Then if the numerator is 0, what is the value? It becomes 0. So it satisfies all the three conditions together. So the value of 0 by 0 may be 1 or infinity or 0. So the value is not exact. The value is not definite. This kind of form is known as indeterminate form. That means the value cannot be determined. So 0 by 0 equal to 1, infinity or 0. It satisfies all the above three conditions together. So the value is not exact. This kind of form is known as indeterminate form. That means the value cannot be determined. Is it clear? Now, let's understand this by taking an example. We take an example from chapter 2, relations and functions. Take one example. We take one function f of x equal to x square minus 4 by x minus 2. Find f of x at x is equal to 2. That means we have to find the value of this function at x is equal to 2. Means in place of x, we will replace 2. F of x equals x square minus 4 by x minus 2. That is the given function. Find f of x at x is equal to 2. That means we will replace x by 2. So f of x becomes f of 2. That is equal to 2 square. X square becomes 2 square. Minus 4 by 2 minus 2. That is 2 square. 2 square is 4. 4 minus 4 by 2 minus 2. That is equal to 0 by 0. This is known as indeterminate form. We get the answer 0 by 0 at x is equal to 2. That means the value of this function f of x at x is equal to 2 is 0 by 0. That is, this form is known as indeterminate form. That means at x is equal to 2, no value. We can determine the value. Then how we find the value of that function? Let's see how to find the value. For that, there is a one concept known as limit. We have used the limit, or using the limits, we can find out the value of the function near to, not exactly to. We find the value of the function near to. Find the value of this kind of function using the concept limits. Is it clear? Here, one number line is given. This is 2. This is how we represent 2 on a number line. This is 2. That means the value of the function f of x at x is equal to 2 is 0 by 0. Then on LHS of 2, that means left hand side of 2, we have values such as 1.51, 0.50, etc. On the right hand side of 2, we have values 2.5, 3, 3.54, etc. And or 2.0001, 2.01, 2.1, etc. Is it clear? This side is known as left hand side. This side is known as right hand side. This is a number line. Now let's find the value of the function f of x at x is equal to 2. So we are not finding the value here exactly at x is equal to 2. Instead of that, we are trying to find the value of this function near 2. Near 2 means that maybe from the LHS or maybe from the RHS. Is it clear? Near 2 means this 1.5 is very close to 2. So we have to find the value of the function near 2 means from x approaching to 2 from LHS or x approaching to 2 from RHS. Is it clear? That is, in particular, this particular x that reaches 2 from LHS or from RHS. From LHS means the value reaching from LHS, it is called left hand side limit. Left hand side value is always less than 2. These all values are less than 2. The left hand side values is always less than 2. So represent it by a negative sign. So if x approaching to 2 from LHS, so all the values are less than 2. So we represent it by a negative sign. X approaching to 2 negative means x approaching to 2 from left hand side. That is the meaning of that. Then x approaching to 2 from RHS means x approaching to 2 from the right hand side. If the value is reaching from right hand side, it is called the right hand side limit. All the right hand side values are always greater than 2. Check 2.5, 3, 3.54, etc. So we represent it by a positive sign. That the positive sign indicates that x approaching to 2 from right hand side. So we represent it as x approaching to 2 plus this plus sign indicates that x approaching to 2 from RHS. Is it clear? This is a number line. This is a representation of 2 on a number line. At 2, the value of the function is 0 by 0 as we explained earlier. This form is known as indeterminate form. The left side values are less than 2, so we represent it by a negative sign. All the right side values are greater than 2, so we represent it by a positive sign. So it is represented as x tends to 2 minus and x tends to 2 plus, or x approaching to 2 minus or x approaching to 2 plus. This indicates that x approaching to 2 from left hand side. This indicates that x approaching to 2 from right hand side. Is it clear? Now we can find that what value this function gives using the limits. That means as x approaching to 2, x value is approaching to 2. That means x value is not equal to 2. X value is not equal to 2. It is less than or greater than 2. X value is less than or greater than 2. Using the limits, we can find the solution of problems which gives indeterminate form of the value 0 by 0. Actually, if we directly put the value, then we can't find the answer. But using the limit, we can find the value of such problems nearest to the x value. Nearest to the x value means x approaching to 2 from LHS or x approaching to 2 from RHS. This negative sign indicates that x approaching to 2 from LHS. This positive sign indicates that x approaching to 2 from RHS. Is it clear? Now, let's understand in detail by using tabular method. This is a tabular method. This is 2. This is x value. This is f of x value. At x is equal to 2, we all know what is the value 0 by 0. That means indeterminate form. Then 1.99 is less than 2. 1.9, 1.8, 1.7, 1.6, 1.5, 1. All the left side values are less than 2. 2.0001, 2.01, 2.2, all the values are greater than 2. These all are left hand side values. These all are right hand side values. At x is equal to 2, function becomes indeterminate. Now, we know that the function is f of x, that is equal to x square minus 4 by x minus 2. In this function, we know we put the value x is equal to 2 directly, we get the answer 0 by 0, which is known as indeterminate form. Now, this is x and this is f of x. We start putting at x is equal to 1, then the function becomes f of 1 equals f of x equal to x square minus 4 by x minus 2. Then f of 1 is 1 square minus 4 by 1 minus 4. What is 1 square? 1 square means 1. 1 minus 4 equal to minus 3 by minus 1. That is equal to 3. At x is equal to 1, function is 3. The value of the function is 3. Similarly, at x is equal to 1.5, we substitute the values here, we get f of x equal to 3.5. 1.6, at that time f of x equal to 3.6. X equal to 1.7, f of x equal to 3.7. X is equal to 1.8, f of x equal to 3.8, etc. So clear? We observe that x value reaches to 2, 1.9, 1.99 is all values are very close to 2. X value reaches to 2, f of x value reaches to 4. X of x value is very close to 4. 3.99 is very close to 4. In the LHS, we know that we see that x value reaches to 2, at that time f of x value reaches to 4. As x approaching to 2, at that time f of x approaching to 4. So, we write x approaching to 2 minus, this minus sign indicate that x approaching to 2 from LHS. The value of the function is 4. Is it clear? Now we take the value from right side. First we take x equal to 3. At that time, f of x equals x square minus 4 by x minus 2. 3 square minus 4 by 3 minus 2. 3 square is 9. 9 minus 4 is 5. 3 minus 2 is 1. So we get f of x equal to 5. X is equal to 3. F of x equal to 5. X is equal to 2.5. F of x equal to 4.5. Similarly, x is equal to 2.001. F of x equal to 4.001. The x value reaches to 2 from the right side. X value reaches to 2 from the right side. F of x value reaches to 4.001. 4.001 is very close to 4. So f of x value reaches to 4. X value reaches to 2 from the right side. Then f of x value is reaching to 4. So we can say that as x approaching to 2 plus f of x approaching to 4, this plus sign indicates that x approaching to 2 from right side. This is the use of limit. We know that we directly put the value at x is equal to 2, we get 0 by 0 4. By tabular method, we realize that x value reaches to 2, f of x value reaches to 4. That means that limit x approaching to 2, f of x equals limit x approaching to 2, the value of function is x square minus 4 by x minus 2, that is equal to 4. That means limit x approaching to 2, f of x equals limit x approaching to 2, this x square minus 4 can be written as 2 square. X square minus 2 square by x minus 2. The x square minus a square equals x plus a into x minus a, or a square minus b square equal to a plus b into a minus b. Here a is x and b is a. So x square minus a square equals x plus a into x minus a. A square minus b square is equal to a plus b into a minus b. So x square minus 2 square can be written as limit x tends to 2 x plus 2 into x minus 2 by x minus 2. These x minus 2, x minus 2 get cancelled. Then limit x approaching to 2, x plus 2 equals, we substitute the value, this 2 here, then we get x, that is equal to, f of x equals 4. Is it clear? Here we can see that directly we put the value x is equal to 2, we get 0 by 0, 4. But using the limit, we have concluded that the value, that is as x reaches to 2, the value of the function is 4. X approaching to 2, the value of the function is 4. This is the use of limit. That means all the problems which are there in the indeterminate form, we can find out such problems value, that is the nearest to value using the limit concept. Nearest to value means x is not equal to 2, x is less than 2 or x is greater than 2. Now, definition of limit. Let f of x be a function, then the limit of f of x at a point x is equal to a is denoted by limit x approaching to a f of x. We use the keyword lim for limit. That is lim x tends to a means limit x approaching to a f of x, or limit x tends to a f of x. X tends to a means x approaching to a from LHS or from RHS, but not x equal to a, or not x is equal to a. It means that when x approaching to a, then where f of x equal to, as x approaching to a, what value of f of x function take place? That is the definition of limit. F of x be a function, then the limit of f of x at x is equal to a means limit x tends to a f of x. We use the word lim for limit. Limit x tends to a f of x, or limit x approaching to a f of x. We let f of x be a function, then the limit of f of x at a is denoted by limit x approaching to a f of x. Is it clear? We can represent the same concept by graphical method. This is a graphical method. This is our x-axis and this is y-axis. X-axis is representing the x value and the y-axis is representing the f of x value. We know that the value of the function at x is equal to 2, the function is indeterminate form. When x is equal to 2, function is 0 by 0. This point is that at x is equal to 2. This is that point. We represent it by a circle like this. That means this point is at x is equal to 2, f of x is 0 by 0. We represent it by a circle in the graph. The circle indicates that in the indeterminate form, when the value is 2. When we solve the problems, we can use tabular method or graphical method. These two are time consuming and complicated methods. This is only for understanding the concept. Is it clear? But generally, we solve the problems, we use factorization method. Directly, we put the value x is equal to 2, we get indeterminate form, that is 0 by 0 form. So we factorize it. For example, limit x tends to 2, x square minus 4 by x minus 2 equals limit x tends to 2, x square minus 2 square by x minus 2. X square minus 2 square or x square minus a square or a square minus b square can be factorized as a plus b into a minus b. Here in place of a, here x. In place of b, a. Or x square minus a square factorized as x plus a into x minus a. So x square minus 2 square is factorized as x plus 2 into x minus 2. Denominator is x minus 2. These x minus 2, x minus 2 get cancelled. Then we get limit x approaching to 2x plus 2. That is equal to, we replace x by 2, it becomes 2 plus 2. That is equal to 4. The main use of limit is that when we solve certain problems, we may get some indeterminate rule, that is 0 by 0. So this function do not have any exact value. To solve such kind of problems, there is a concept of limits. Using this concept, limit can be find the nearest to value. That means not exactly at that value. In this case, not exactly at x is equal to 2. We can't find the value at that point. As x reaches to 2, then we find that what is the value of f of x. From the above example, we see that x reaching from LHS as f of x reaching to 2 or x approaching to 2 from RHS. At that time, f of x reaching to 3.99, that is very close to 4. So we know that at that time, f of x approaching to 4. In both the cases, at as x approaching to 2, f of x approaching to 4. Is it clear? As x approaching to 2 from LHS or x approaching to 2 from RHS, it reaches 2. Sorry, it reaches 4. X approaching to 2 from LHS and RHS, f of x approaching to 4. Is it clear? As x reaching from RHS and f of x value reaching to 4.00, that is very close to 4, or 4.01 or 4.1, etc. So final conclusion is that as x approaching to 2, f of x approaching to 4. This approaching to 2 means that the final conclusion is that x approaching to 2 from LHS or x approaching to 2 from RHS. This plus sign indicates that x approaching to 2 from RHS. This minus sign indicates that x approaching to 2 from LHS. In both the cases, f of x approaching to 4. Is it clear? Thank you.